Okay, this is for lesson 7.3, Introduction to Logarithms. First thing we got going on here is what is a log. So if you look at the blue line over here, y equals 2 to the x, we just got done with things in the form of y equals a times b to the x. So if we talk about y equals 2 to the x, our initial value is 1 because there's a 1 in front of it. Our base is 2 raised to a power. So we have 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4. There's my 2, 4. So that's not new material. That's what we've been doing in 7.1 and 7.2. The second thing we're going to bring into play here is the fact that a logarithm is really the inverse of that graph. So here's the inverse of it as it's graphed. If you remember, inverses are reflections over the line y equals x, because what do you do from last chapter if you're talking about an inverse is you interchange the x and the y's. So if I interchange the x and the y's, I get x equals 2 to the y. But now we run into this problem where how do I get the y by itself? And that's where we bring in the logarithm. A logarithm is an exponent. So if we say that a logarithm is an exponent, that's where we say that y is the exponent is equal to the logarithm. We always put a base. The base goes right here, and then what it's equal to goes over here. Okay, so don't be scared of logarithms. They're not going to hurt you. We would say y equals the log base 2 of x here. So when we graph this, these two things are the same thing. A log is equal to an exponent. What was the exponent? This is the base. 2 raised to the exponent equals this. If you look over here, here's the inverse. X equals 2 to the y. That's the same thing as log 2 to the x. And this is what the graph is. Remember, an inverse interchanges all the points. 0, 1 turns into 1, 0. Now I have an asymptote that'll be the y-axis instead of the x-axis. Our main objective today is only to get you to interchange things from exponential form into log form and back again. So that's what this tells you, and this is also in your book, and there are a bunch of examples in your book, some of them that we'll do here today, but you could take a look at a couple other ones as well. Here's the main thing that you need to pull from this, right here. Notice again it says that b is going to be positive. That's very important. Our base will always be positive. Negatives would cause a wide variety of problems similar to when we had to use absolute values. We're not going to worry about that right now. B is also not 1 because if it's for the same reasons our exponential couldn't be 1. So what we have here is if we're in the form b to the y equals x, and we want to write it in log form, so this would be considered exponential form, and now we're going to write it in log form. So we're going to write it log, the base is b. The base is what is being, you're going to raise your exponent to. Base is b. They usually use base b because you listen to the base go booyah. And a log is equal to the exponent, so we know that the x will go here, and this is my exponent. And you can see the y is the exponent. Exponent is what a log is equal to. It goes out there. Base goes down below. That's the x. This will happen every time. Here's an example, and this is one that could be solved. Here's the log base 3 of 27 equals y. This is the base. A log is equal to an exponent equals 27. We could actually solve this one. 3 to the what equals 27? 3 to the third equals 27. So y would have to be 3 in that case. Let's look at some examples. Write this log base 3 of 9 equals 2. That's how we read that. Log base 3 of 9 equals 2. You can write this as the base raised to the exponent equals what you're taking the log of. This is a true statement, isn't it? 3 squared equals 9. If I just told you 3 squared equals 9, you would have said, no kidding, rocket science. But if I tell you log base 3 of 9 equals 2, everyone looks at me with a blank stare. Don't look at me with a blank stare. Think about the fact that a log is equal to an exponent. Look at this one down here. If a log is equal to an exponent, what's the exponent going to be? Everybody should be saying -2. This has to be the exponent. This is the base. You raise a base to an exponent. 10 to the -2 equals 1 over 100. True statement. Remember, -2 would be 1 over 10 squared. 10 squared is 100. A log is equal to an exponent. Have I said that yet? Base raised to an exponent equals this guy right here. More examples. A log is equal to an exponent. 3 is the exponent. That means it's this one, not this one, not this one. Boom, boom. What's the base? 2. 2 cubed equals 8. 2 cubed equals 8. Hey, it's letter B. Wonderful job. Base 2 exponent 3 equals 8. 2 cubed is 3. Log base 2 of 8 equals 3. I was supposed to let you try that one. You should try this one. Do it. I'll wait. I'm waiting. I'm still waiting. I'm waiting for the person that's saying, I have no idea what I'm doing. Ask the person next to you. Stare blankly at the front screen. Here we go. A log is equal to an exponent. -2 will be my exponent. The base is 3. 3 raised to the -2 equals 1/9. Nice looking 9 I got here. Did I hear a 9er in there? Do we have a 3 raised to the -2 equals 1/9? There it is. Base goes on the bottom. Log is equal to an exponent. Goes up there. This is wonderful stuff. Uh-oh, now we got to write in logarithmic form. Log base. What is on the bottom? Which one has the exponent? Got to be 27. Base 27. What is the exponent? That's what a log is equal to. Log is equal to 1/3. Fill in the 3. 27 to the 1/3 equals 3. Wonderful. Here we go again. Log is equal to an exponent. It'll be equal to 3. What if I put the 3 over here? Would that be crazy? It wouldn't. Log base 5 of 125. 5 to the 3rd equals 125. A log is equal to an exponent. 5 is the base. That's what its exponent is. Isn't this fun stuff? It's awesome. Write the next one. 3 to the 4th equals 81. A log is equal to an exponent. Do I have an exponent? I do. It's number 4. What is the base? The base is 3. The base is something that's being raised to a power. So I mean, you could always do this. B to the x equals y. And how do we change these forward and back? Log base b of y equals x. X is the exponent. Log base 3 of 81 equals 4. 3 to the 4th equals 81. Log base 81 of 9er equals a half. 81 to the 1/2 equals 9. A log is equal to an exponent. Transposing things from exponential form to log form. Oh, now we got to solve them. If you've got a problem, I'll solve it. 3 to what power equals 243? Well, couldn't I just write it like this? And isn't this a problem from 7-2 now? 3 to what power? 3 to the 1 is 3. 3 to the 2 is 9. 3 to the 3 is 27. 3 to the 4 is 81. 3 to the 5 is... 3 to the 5? It's not 81. It's not 243 either. It's 160 something. I could be wrong. I have no idea. Maybe this is 3 to the 4. Maybe this is 81 times 3 again. Oh my gosh, it is. Took me that long to figure that out. Oh, jeez. 3 to the 4th, or 3 to the x equals 3 to the 4th. X equals 4. 3 to the what equals 243. 10 to the what? 10 to the what equals 1,000. 10 to the what equals 1,000. 10 to the what equals 10 to the third. Boom! X is 3. Awesome. Awesome. At Earth's surface, the air pressure is defined as 1 atmosphere. Pressure decreases by about 20% per mile. Oh, this is a exponential growth or decay problem, because they went with a decay of 20%, so it was really starting with 1. So they started with 1. So this is a y equals a times b to the x, which was pressure at time x was equal to 1 times 1 minus 0.2 to the x. This is a little recap of what we did the last couple of days. 0.8 to the x. They gave it to you. Wasn't that fun? X is in miles. Find the atmospheric pressure in atmospheres at an altitude of 8 miles. This is just 0.8 to the 8th. Can you do 0.8 to the 8th on your calculator? I hope so. The next one, they ask you to, they kind of show you how to do it. I didn't make a copy of it, but they want you to do the inverse of p to the, if you're doing if you have p equals 0.8 to the x, if you want the inverse, then it's x equals 0.8 to the p, but we want to solve for p, so we have to do the log. So I have log with a base of 0.8, base of 0.8, log with a base of 0.8 of x equals p. 0.8 to the p equals x. So all they're looking for is you to transform that. Most of the stuff in 0.8 is going to just be changing from log form to exponential form and exponential form to log form. You want to look at the front section of the book. There's probably more examples there. If you want to go to Googly, put in log form to exponential form, somebody will have a video that will look a lot like this. They'll have a different voice. It might not be as fun though. Have a wonderful day.